Hello guys, welcome to Sergei's Chemistry. Today we are looking at potassium manganate 7 and different colors of it. And especially we are going to reduce it at different pH. So, what is potassium manganate 7? Purple solution at high concentrations looking almost black. Oxidation state of manganese ions there is +7. When it is going to be reduced, oxide ions would be removed from the complex. I put it in the watch glass because the color change is a bit better to see there. So now, the amount of reduction would depend on pH. Normally we do reduction in acidic conditions, and I'm going to create these acidic conditions on the right. So I'm putting sulfuric acid on the watch glass in the right. I would leave the watch glass in the middle as it is with pH 7, and I would make alkaline conditions on the left with sodium hydroxide. So, okay, sodium hydroxide, we have different pHs, a lot of hydrogen ions here, some moderate amount in the middle, and virtually nothing on the left. Now, it's the time to look at reducing agent which I use. It's sodium sulfite, or another name, sodium sulfate 4. Oxidation state of sulfur is 4 here. It's SO3 2-, not SO4 2- as in sulfate. Sulfate though is stable oxidation state +6. So you see, sulfite is oxidized into sulfate, producing 2 electrons, giving 2 electrons away. Sulfite is colorless, sulfate is colorless. All color changes would be due to changes in manganese ions. So here you see I've forgotten to acidify flask, and now I'm putting sulfuric acid on the right and sodium hydroxide on the left. And now it's a time to add reducing agent. Sodium sulfite here supposed to reduce manganate 7 into manganese 2+ ions. Yeah, it was not enough of it, but now you see manganese 2+ ions, they're virtually colorless. Here we put it in the pH 7 conditions. We have a distinct brown precipitate. That's manganese 4 oxide, which is solid. And on the left you see that the color actually changes into green. Surprisingly, it's manganate 6 ions. So the same thing we are going to see here in the watch glass. And also I would give you equations so that you would see exactly the chemistry behind. So here in acidic conditions, yeah, colorless manganese 2+, you see a lot of hydrogen ions are here. 8 hydrogen ions are needed to remove oxide ions from manganate, and 5 electrons are given to 1 unit of it. Oxidation state is changing from +7 to +2. Okay, here in the middle we don't have enough hydrogen ions, and reduction cannot proceed to the completion. So instead of proceeding to +2, it proceeds only to +4 in manganese 4 oxide. And you see hence brown precipitate. Only 3 electrons from +7 to +4. Not enough hydrogen ions, so only 4 per unit. Here in alkaline conditions you see, okay, very beautiful green color, and it's because of manganate 6 ions. You see, here is virtually no hydrogen ions to remove any oxides from the complex. So the only way to reduce is just give 1 more electron. So the complex with charge -1 is becoming the same complex with charge -2. And oxidation state is changing from +7 to +6 only. At the same time, if you are attentive enough, you see that the color is changing already. It's not as intense green. It's actually disproportionating. If you wait a few more minutes, disproportionation is really visible. Disproportionation reaction, oxidation and reduction at the same time, is written on the top. So end result is brown precipitate. This beautiful green color is fleeting and exists for very small time. It would break down, so I cannot keep it. And the result is more or less the same you see in neutral conditions in alkaline, brown precipitate. Here on the right, in acidic conditions, it's actually proper reduction of manganate 7 in acidic conditions. You see, during titration, I put oxidizing agent into reducing one, and the color would disappear if there is enough reducing agent in. Yeah, purple manganate 7 into colorless manganese 2+. End point of titration would be permanent pink color remaining. It means all reducing agent is gone. Thank you for watching. Please subscribe to the channel. See you next time. Bye.